Okay, this should be the handout that you see. This is our last day of algebra review before we start geometry. And we're going to be looking at proportional relationships. Okay, there are certain proportions that are really common that you may have seen in algebra, like part A right here. This kind is actually kind of nice. We can do a real quick shortcut on this kind of an equation to solve it for our variable. If you see one fraction equal to another fraction, a really easy way to solve that is through multiplication first, but you want to multiply diagonally. So I'm going to circle two things and I'm going to multiply together. I'm going to multiply x and 6 together. I'm going to write that down, 6x. And then I'm going to go and multiply 12 and 7, the numbers that are diagonal to each other. And I'm going to write that down on the other side of my equal sign. That gives me a smaller equation to actually solve. So once I get that, all my fractions are now gone, and I just solve this for x. So we would divide both sides by 6 to get x by itself, and x would be equal to 14. That's a special case. That's, again, when you see one fraction equal to another fraction. Okay? Some people call this the butterfly method because it looks like a butterfly. Okay? Next one we're going to look at, also a proportional relationship, but this one, part B, that's one you guys know how to solve. So we're not going to talk about that much. You guys are going to do that one. Same thing with our third one, part C. Part C, that's another equation that we know how to solve. We've solved some of those along the way. You guys are going to do that. We are going to go over D together. Part D is a little bit different in that our variable is in the denominator. It's in the bottom of the fraction. So just like any other fractions, any fraction busting we do, anything like that, remember a fraction's division. Part D means 9 divided by x. So we cancel that out, remember, by multiplying. So we need to multiply both sides of our equation by x. And I'm going to write above it here what we would get, 3x equals 9. Our x's would cancel out. This would give us a solution of x equals 3. Okay, the next thing that we're going to look at okay, there we go. Get my screen correct here. We're going to look at how we can classify a relationship. Can we classify it as directly proportional or inversely proportional? Directly proportional is really easy. Directly proportional just means multiplication. Okay? One variable is being multiplied to get the other variable. Inversely, also still kind of easy sometimes. Inversely just means we're dividing by one of the variables. And that's really important because we want to make sure that it's the variable in the bottom of those indirect proportions. Okay, that gives us the indirect relationship. So those are the ones that we want to really be careful about. If you see anything that looks like these two right here that I'm circling, y equals some number times x, or x equals some number times y, okay, that is a directly proportional relationship. Direct proportion, right? One grows, the other one grows. The other one with division, that's inversely, but it's not always inverse just because you see division, okay? The variable must be in the denominator. So I'm going to put a little extra note here. Variable in the denominator. The variable has to be in the denominator for it to be inversely proportional. Okay? This k that we see here just has kind of a fancy name. The k really just stands for a number, but this number, the k, we call that the constant of variation. Constant of variation. Okay? That's the number we're either multiplying or the number that is getting divided. Okay, that's called the constant of variation. So if you see that term constant of variation, that's all we mean. We just mean that number. So if you ever have to find the constant of variation, we mean find that number. That's all we mean by that. So we're going to take a look at several here that we're going to do together. And we're just going to say whether or not this is an inverse or a direct proportional. Okay? So again, if anything that is multiplication, we can look at and we can already say that it is a direct relationship. Okay? So if I look at these, part D, for example, is just a multiplication. So that's directly proportional. Okay? It's a direct relationship. So is part G. That's another easy one right here we can look at. It's just a multiplication. It's a direct relationship. Both of those are direct. Let's look at the other ones. The other ones definitely have some fractions in them. But again, go back to that previous page. Your variable has to be in the denominator. But we also want to be careful. We want to make sure that the variables are also on opposite sides. So we want to answer two questions. Variable on opposite sides, and is it the variable in the denominator? Okay. So if I run into something like part A, notice my variable is not in the denominator. It doesn't really match the formats exactly because the x is on top. So we can kind of view what's happening in that relationship just by solving it for that x. So if I actually multiply by 5 on both sides of that equation, I can get a better glimpse of what kind of relationship that is. Because my 5's will cancel out, and the x would equal 5 times y. So that's another one that is direct. It is a direct relationship. Okay. If you look at parts B and C is the next two we're going to look at. Part B, this one does match the format that we have on the previous page. Right? The variables are on opposite sides. The variable on the fraction, that's down in the denominator. Therefore, this is indirectly proportional, so we would just write indirect. Part C is another one that looks kind of funky because part C, both the variables are on the same side. If both the variables are on the same side, we need to do something to get one of those variables on the other side. Okay? The only tool we have to do that when we see division, part C has x divided by y, is we can multiply. Always multiply by what's in the denominator. So we would multiply both sides of our equation by y. My y's would cancel out on the left, leaving x equals negative 7y. Well, there's no fraction. My variables are on opposite sides, therefore that actually is direct. Okay, so check those two things, right? For indirect, we want to check and make sure variables are on opposite sides. And we want to check for division with a variable in the denominator. If we have both of those things, we have an indirect relationship. If we don't, and we just see that multiplication, it's direct. Okay? If you do not have one of those two things, then you may need to solve your equation for one of those variables. Like when you have both variables on the same side, get one variable on the other side by canceling it out. Okay, next we're going to look at how to actually answer some questions that'll be similar to our homework. Okay, on each of these, we're going to be looking at trying to figure out what k is. K is that constant of variation. It's that constant number being used. It's being multiplied by a variable or divided by a variable. Let's take a look at how we would do that. Part A, we have x equals k times y. That's a direct relationship. And we want to solve for k, but we want to do it when x is 2 and y is 3. So we would just put in a 2 in place of x. X is equal to 2, so I put a 2 in place of x. We don't know what k is. We do know what y is. Y is 3. So we would put times 3. Instead of k times y, k times 3. I can simplify that just a little bit. 2 equals 3k. We'd always put that number in front if we're multiplying. And then if I solve for k, divide both sides by 3. 2 divided by 3 is going to give you a decimal, but the nice way to do that is just leave it as a fraction, 2 divided by 3. So I can just leave it like that if I'm going to get a decimal. There's nothing wrong with that. In fact, that's more exact. Part B, same thing. Put in a 3 for the x and a 5 for the y. We know that x is 3. We know y is 5. Replace the x and the y with those numbers. We don't know what k is, but we know x is 3. We know y is 5. We have k divided by 3 equals 5. We solve that by multiplying by 3 on both sides of our equation. 3 times 5 is 15. Okay, if we look at our next page here, number 4, we're going to write an equation for each statement, solve for the constant of variation, and then solve the actual problem itself. Okay? So we've got to pay attention whether it's directly or inversely related. If y, let's write that first, let's just go in order, varies directly, our first variable would be on one side. If it's directly, it's going to be a multiplication. So it varies directly as x, meaning I'm going to be multiplying k by x. Now I've kind of turned it into the problems we just did. We know y is 12. We don't know k, but we know x is 3. We divide both sides because k is being multiplied by 3. Divide both sides by 3. And we find that k is equal to 4. So now we have our constant of variation. So what we can do with that is we can rewrite our equation up here at the top and write it as y equals 4x. That would be the equation for the situation. Now we're ready to actually solve what we're looking for. It says find y when x is 16. So we're looking for y when x is 16. So that's kind of nice because now it just says y equals 4 times 16. So we just multiply 4 and 16 together to get our actual answer of 64. To do inverse, we start the same way. Start with your first variable. It says if r, I can go ahead and write r equals, varies inversely as t. There's our other variable t. Remember, your variable has to go on the bottom. And your constant k has to go on the top. Okay. So r is 18 when t is negative 3. r is 18. T is negative 3. K divided by negative 3 on one side. That means we need to multiply by negative 3. So if I multiply both sides by negative 3, k is equal to negative 54. And then again, we would write out our equation. R equals negative 54 divided by t. We want to find r when t equals negative 9. So we replace t with negative 9. And we would just simply do that division. Negative over negative, that cancels out, makes a positive. 54 divided by 9 gives us 6. And then we're just going to do one example from the back page. Couple of examples in context. Let's look at part A. A grocery store sells a bag of 3 oranges for $1.23. Latanya spent $3.28 on oranges. How much did she buy? Excuse me, how many did she buy? We don't know how many she bought. We also do not know how much a single orange costs. Okay? So if we say R is the cost of a single orange, that'll give us a variable. You can use something other than R if you want. R is the cost of a single orange. A bag of oranges is 3 oranges. So we can write that as 3R. That would give us our 3 oranges. We have 3 R's, or 3 oranges. So we do 3 times the cost to get that total for the bag of $1.23. If we solve that for R, we're going to get how many dollars per orange they cost. So we would divide both sides by 3. 1.23 divided by 3, 0.41. This is how many dollars, or cents in our case, per orange. Now that we know how much each orange costs, we know that every single orange costs 41 cents. We don't know how many oranges she bought, so we're just going to make that a variable. X is going to be how many oranges. Well, we know she spent a total of $3.28. Okay, so we solve for X. That's how many oranges. So we would divide both sides by 0.41. 3.28 divided by 0.41 is going to give us 8. So she bought 8 oranges. Okay, we've definitely skipped over some problems on here. So we're going to go back and work with our teammates and work on correctly solving the rest of the problems on today's handout that you have in front of you. Okay? Remember to ask questions. You can also message me on Canvas, but I may not see that until the very next day.